Okay, today in Math 20-1 we're going to look at topic 4.4, using the quadratic formula. Now, another way that we're going to use to find the roots or to solve quadratic equations is to apply the quadratic formula. And what we're doing is that we say in a quadratic equation, ax squared plus bx plus c, when it's equal to 0, we can find the roots directly, x, as negative b plus or minus the square root of b squared minus 4ac divided by 2a. A, b, and c are the parameters of our quadratic equation. Let's look at an example. In the equation 3x squared plus 5x minus 2 is equal to 0, a has a value of 3, b has a value of 5, c has a value of negative 2. So when we take our quadratic equation, as it is there, we're going to do the substitution. We will say x is equal to the negative of b, which is negative of 5, plus or minus the square root of b squared, which is 5 squared, or 25, minus 4 times a, which is 4 times 3, times c, which is negative 2. All of this is going to be divided by 2 times a, which is 3. That means our roots are going to be negative 5 plus or minus the square root of, well, we simplify the part underneath the square root sign. That's going to be root 49 over 6, which happens to work out very nicely in this case. So it's going to be negative 5 plus or minus 7 over 6. This means there's going to be two roots, negative 5 plus 7 over 6 and negative 5 minus 7 over 6. Negative 5 plus 7 is going to be 2 over 6, which reduces to 1 over 3. Negative 5 minus 7 over 6 is negative 12 over 6, which is going to be negative 2. Those are going to be our two roots, or two solutions to this quadratic equation. It also means that if we graphed it, those are going to be the x-intercepts. One's going to be at negative 2, and one's going to be at 1/3. Now, the part underneath the root sign, the b squared minus 4ac, has a special name. It's called the discriminant. D is equal to b squared minus 4ac. That equation you're going to be given on your test. That tells you the discriminant. Now, what does this part underneath the square root sign tell us? Well, the discriminant will tell you whether this will be two distinct roots. That means two different roots, as it was in our first example. This is when b squared minus 4ac is greater than 0. Well, there will be two equal real roots. This will happen when b squared minus 4ac is going to equal 0. Or two non-real roots, and this is going to happen when b squared minus 4ac is going to be less than 0. And we're going to do a couple of examples to show when these two cases are the same, or are going to be applied. Now, what does this look like? Well, two distinct real roots, as in our example, means that there's going to be two x-intercepts, and our graph is going to cross the x-axis in two different spots. There's going to be two equal real roots, and that means that the graph is going to touch the x-axis in only one spot. That means that there's going to be one x-intercept. And lastly, this is where our graph does not cross the x-axis. These are two non-real roots. This will happen when b squared minus 4ac, or we're going to end up with a square root of a negative number. And there'll be 0 x-intercepts. Let's use the quadratic equation to determine the roots of the following equations. For example, in number 2, 1/4 times x squared minus 3x plus 9 is equal to 0. And in example 3, where 3x squared minus 5x is equal to negative 9. When we apply the quadratic equation, you're going to end up with positive 3 plus or minus the square root of 9 minus 4 times a, which is 1/4, times c, which is 9, over 2 times 1/4. And you're going to end up with 3 plus or minus the square root of 0. And the square root of 0 is 0, so there's going to be two roots, 3 plus root 0 and 3 minus root 0, which is both going to give you the same number, 6 or 6. This is the case where b squared minus 4ac is equal to 0, and you're going to get two equal real roots. What do you notice? Hopefully, you're going to notice two things. The first thing is two equal real roots, and secondly, that the discriminant is going to be 0. In the second case, we're going to add 9 to both sides, first of all. Now we can apply the quadratic equation, and you're going to get positive 5 plus or minus the square root of negative 5 squared is 25 minus 4 times 3 times 9 over 2 times 3. This is going to end up with 5 plus or minus the square root of negative 83 over 6. This is as far as we can go because we have the square root of negative 83. We can't find the square root of negative 83 because it doesn't exist. Therefore, it's as far as we can go. All we can say is that there's going to be two non-real roots. Since you can't determine the square root of a negative number, there's no real roots. And your assignment for this section is to do page 254, numbers 1 A, B, C, D to 7 A, B, C, D, and numbers 8, 9, and 10.